And from Jim, this was my greatest learning experience in my 68 years of learning about soil. Jim, it's fantastic to have you here. You are one of my all-time favorite farmers by far. And finally, the knowledge, wisdom, and warmth were unmatched. I walked away every session having learned so much. I'm leaving this course feeling much more competent and excited about working on the land. It's been incredible to learn from Jo, and the Regenerative Living portal always works so seamlessly. I'm so grateful I discovered this. So, welcome everyone. Welcome to From Dirt to Dollars Cultivating Living Soil online course with Jo Tobias. It's such a pleasure to have everyone here. My name is Javin Bernakovich. I'm hosting for Regenerative Living today. And today marks the launch of Jo's online course, The Art and Science of Cultivating Living Soils. The more of us who understand how soil actually works and how to work with it will prepare us better for the challenges ahead. So thank you for being interested in living soils and for being part of creating a more resilient future. I so appreciate it, and I know Jo does as well. Our time today. So first and foremost, I'm going to give you a very short introduction to regenerative living and an even shorter introduction to the course. And then Jo is going to give you the course in miniature. She's going to give you a 45-minute presentation about living soils, as well as an amazing case study, which really showcases what you can do when you understand how living systems work within the soil. Then for those that are interested, I'll have a time offer. So there'll be a time to offer between now and Sunday. If folks want to jump into the course, there'll be an opportunity. And then we'll have the Q&A. So again, if you have a question, please make sure to put it into the Q&A at the bottom of the page as opposed to the chat. I've left the chat open, so if there's things you like or interested in and you want to start populating the chat, there's an opportunity there. So Regenerative Living is an online educational platform offering teachers from world-class practitioners. The focus is on practical skills to live on the planet as if we intend to stay. It's built on my 16 years of experience as a regenerative land designer and installer. To that point, I've currently, since 2009, worked on over 150,000 acres across the world, from Kenya to India, Canada to Ecuador, helping people to catch and store water, build profitable production systems, and create landscapes that improve year after year. And as living beings, we are ecology, and over time, I've learned how to apply that same ecological lens, principles, and practices to people. That means I've helped colleagues and clients design and improve their businesses, make better decisions in their lives, and create systems that are resilient, adaptive, and life-giving. Just like ecosystems, we try to ensure that everything is connected and to treat people like systems. So I've helped a number of my previous students get into regenerative business. I've also had an opportunity to work with colleagues and help to improve their businesses over the years. But back in 2019, I started noticing that many people were stuck with their own isms and ologies. They were becoming recalcitrant, hardened, and unyielding. So I reached out to my good friend and regenerative soil consultant, Jo Tobias of Root Shoot Soil, and together we offered the very first class of regenerative living, the art and science of cultivating living soils. Since then, we've had an incredible explosion of over 20 different courses in the last 5 years, because when I started this work 16 years ago, I spent thousands of dollars traveling thousands of kilometers all over the world, trying to learn all the things I wanted to learn to be able to steward land well. And it was worth it, but I wanted to create something different, a place where people could get the same high quality experience on a subject without having to spend a huge amount of money and fly halfway around the world. So regenerative living was built so you can learn from world-class practitioners right where you are. And our catalog has grown exponentially. We have practical skills about how we work and develop landscapes, how we farm, how we take care of our family's food security, how we even start to tell our stories digitally. And we have an exciting collection of courses coming up. Everyone here gets updates, so don't worry, you'll obviously be able to know when it's up. In a week and a half, I'm going to be sharing values-based decision-making, a way of creating values and directing towards the life you've always wanted. We're also going to be offering Built to Last, the Science of High-Performance Homes, taking a look at how do homes actually work, structures actually work on farms and landscapes, and what can we do to actually make them better. Scott Gallant's coming back for syntropic farming, a syntropic agricultural conversation where students previously, 80 students we had last year, said it was the best syntropic farming class they've ever taken. And again, Ryan Merrill's coming back. We're going to be doing sustainable social media. We all know we have to share our story. It's just sometimes insurmountable to think we have to be on social media. So how do you do it? You do it sustainably. And Ryan's been phenomenal with that. And for the first time, I'm going to be sharing values-based decision-making in an immersive 9-month process for those that are interested. But today we're here to talk about cultivating living soils with Jo. Jo's a regenerative living soil consultant, and as I said before, quite possibly one of my favorite people in the world. And I think that's because she's down to earth. She has a wicked sense of humor, but she also knows what she knows. She knows what she doesn't, and she's very skeptical. She has a very scientific mind. And so when she's working with land stewards, farmers, and producers to improve their soil structure, it's through a rigorously scientific approach, but also an art of listening deeply to the land and to its stewards. When we started working 5 years ago, Jo was consistently helping farmers from Canada, but today she helps producers from all over the world. She's kind, she's compassionate, she's incredibly intelligent, and she's dedicated to this work in a way that I think few others are. To that point, Jo is under the weather today, and so she might be on and off audio so she can take care of some coughing and some sneezing. And we're so grateful that she's decided to stretch and be here today. So, the art and science of cultivating living soils is the most complete soil biology training that we've ever offered. If you want to understand soil biology, build real fertility, and stop wasting time and money on things that don't work, this is the fastest path to a biological understanding of your soil. But the real problem is that most people try to fix things by adding them inputs, amendments, fertilizers, and none of it sticks because the biology and the structure aren't there. Plus, if you don't understand the system, you can't change it. That's what this course changes. So the solution is simple. You need a system for understanding soil biology and a clear method for improving it. And Jo gives you both, a complete framework based on real science and field experience. And by the end of today, you'll understand why so many people call this the most complete soil course they've ever taken. Before I get into the course, Jo is going to give you a course in miniature, a little introduction to living soils, to herself, and to the way she works with individuals. Jo, thank you so much for being here. It's such a pleasure to host you again. And I'm really excited to see the updates because for those that have seen the Little Dog Farm case study, you've actually brought in the improvements because the people you work with are always improving their soil. So thank you for being here, Jo.
Thank you for having me here, Javin, and thank you everyone for carving out some time in your day to be here with me. I just want to apologize ahead of time. Like as Javin said, I'm going to be maybe turning the audio off and on just to so that I can manage my throat here during the presentation. But I'm just going to go ahead and yeah, let's walk through this the art and science of cultivating living soils. Can you see that okay, Javin?
Looks great, Jo.
Okay, great. Let me just move us out of the way. Okay, I like to start off my session with a little quote. When we think of stewardship in relation to soils, we think not only of carefully tending the soil, but also of guarding it and protecting it from harm. Even a stewardship often connotes caring for something that does not belong to you. Soil stewardship involves caring for something that has been entrusted to us by nature and whose benefits are there to be enjoyed down through generations. So again, thank you for having me here today. I just want to quickly introduce myself to everyone before we begin. My name is Jo Tobias. I own and operate Root Soils, which is a company that specializes in regenerative soil and living compost. I have been since 2015 collaborating with farmers across Western Canada, and internationally as well. My work centers on helping land stewards like yourselves have a better understanding and relationship with your soil. And in my efforts to regenerate degraded landscapes, I discovered that well-managed compost can serve as a powerful tool. It can really help kickstart ecological processes such as nutrient cycling and decomposition. So my journey actually started back in 2010 when I transitioned from computing science to permaculture and eventually soil ecology. It was the pivotal moment came when I visited my family in the Philippines and I saw firsthand the lingering effects of the Green Revolution in the small farming communities where I'm from. So, as many of you probably already know, that revolution aimed to feed the world through technology, more hybridized crops, more synthetic inputs. But in the rice farming villages where my family lives, that approach actually led to the widespread adoption of hybridized rice cultivars that demanded heavy fertilizer and chemical or pesticide use. And it really pushed aside traditional cultivation methods, including the reduction of heirloom rice varieties. So seeing that gradual loss of knowledge and resilience shifted my path towards what I'm doing now. So I'm glad that you're here with me today. So we're going to explore one of the case studies throughout the session and how we were able to achieve that. How are we able to go from basically desolate, deserted landscape to a thriving ecosystem? So this is our agenda today, soil and soil health. We're going to talk a little bit about biological inoculants, so compost, compost extracts, and compost teas, and when we did either one at Little Dog Farm, which is our featured case study today. So in the chat, feel free to just share what soil means to you. I'm going to take a look at what everyone writes later, but I just want to get a sense of what soil means to you. Maybe Javin can, yes, Vanessa says life. Thank you, Vanessa. Amazing. Maybe Javin can also chime in. Anna contains nutrients. Jessica, an entire ecosystem we are starting to understand more. Great. Thank you, everybody. Food resiliency from Brenda. Exactly. So soil is an ecosystem. It is a community of living organisms merged with the non-living components acting as a system. Mildred also mentioned foundation of society. Exactly. So soil is complex, and I don't think we need to shy away from that complexity. We deal with complexity on a daily basis. Our relationship with loved ones are complex. So is the relationship that we have in our farm or in our garden. But if we just learn how to listen to what your plants and soil tell you, then we can really understand that complexity a little bit better. So here's a slightly different way of looking at soil, but the same sort of thing that we just talked about. Soil is made up of solid, liquid, and gas. So it's a mixture of those components in varying proportions. The solid components are made up of your mineral matter, your organic matter, and your biota. So the mineral matter that consists of your sands, silts, and clays. There are also different types of organic matter found in soil, and of course, the living organisms. So soils that are intensively managed, constantly disturbed, tend to have very low biological diversity and very simple forms of organic matter. And then you have the liquid, the soil water containing dissolved ions or nutrients moving through pore spaces. And you also have gas or the soil air. There are many different types of gases found in soil, from laughing gas to oxygen to carbon dioxide to hydrogen sulfide, and all these different gases are produced by microorganisms. So healthy soil keeps a dynamic balance between liquid and gas in these pore spaces. And these pores are your highways. This is your network. This network aerates or ventilates the soil. When water enters the soil, the network becomes blocked, and the water allows those nutrients to be transported through the soil. So your soil water delivers the food to the root system. It sort of tells you who is getting what in this moment in time. So when water leaves, air comes in, providing oxygen to aerobic organisms and plant roots. So soil air and soil water are interrelated and are dynamic parts of the soil. These are the two components that we tend to really forget about. We tend to talk a lot about sand, silts, and clays or soil texture. We talk a lot about organic matter. Finally, we're starting to catch on to the idea that soil is actually alive. It has living organisms. But these two components are, I would say, subjects that we have yet to explore a little bit deeper. So Walter Yanni, a soil microbiologist and climate scientist, suggests to add nothing as a way to restore soil health. And if I can also just prompt everyone, what do you think he means by adding nothing? So the question is, what do you think he means by adding nothing? Open space. Exactly. Thank you, MJ. That's exactly right. He means to encourage these cathedrals of voids. So building these complex nothingness in soil is another way at restoring soil health. And we can do this by restoring the soil community. Which leads us right to the slide as to why we need this community. So Dr. Graham Sterling, who is based in Australia, inquired, why are most agricultural soils today often bacterial dominated? They have lost their fungal biomass, fungivorous arthropods. So these are the organisms that feed on fungi. If there's no food or habitat for them, they're not going to be around. And the macrofauna population. I would even go as far as significant reduction in the microfauna population, like your diverse nematode functional groups or tardigrades. So in general, these organisms support nutrient cycling and decomposition, and when they're currently absent in many of our intensively managed agricultural systems. And there are a whole host of factors combined that reduced and disrupted organism population. So let's quickly go through as to why we have lost the fungal community and the predators that go along with them. It's almost like losing the wolves in a forest. So that's what I mean by predators. So a list of factors as to why plant selection, our preference for fast-growing plant species. So we tend to lean more towards quick annuals, like your cereals. Many of our vegetables, plants that have fast turnaround times, tend to lean more towards a bacterial composition in the soil. We also have simplified organic matter inputs. What types of organic matter are you using? Are they complex? Are they harder to decompose? Or are they labile, simple organic matter? Reduced soil habitat complexity. So we have a lot of our agricultural systems, they have fewer, weaker aggregates. So simplified environments actually discourage fungi, such as bare soil. Physical disturbance, so intensive tillage, overgrazing, heavy traffic, and saturated soils break fungal networks. Fertilizers also inhibit fungi. High frequent application of soluble synthetic inputs suppress decomposer fungi. Frequent intensive tillage disrupts mycorrhizae. Phosphate fertilizers suppress mycorrhizal fungi. So high phosphate reduces plant dependence on mycorrhizal fungi. So the challenges involved in restoring a more balanced and fully functional biological community to agricultural soils should not be underestimated, as most soils used for agriculture have been under intensive management for at least 50 years. This is a blip in the Earth's lifetime. We have re-engineered the soil to favor bacteria. Not to say bacteria is bad, but we've reduced diversity significantly. So it's reasonable to ask, can these changes be reversed? And the answer is absolutely. First, by recognizing that there are complex relationships between the diverse flora and fauna found in soil. The soil food web, as many of you already know, is a term that's been used since the early 80s, and it's basically the complex relationship between all these different organisms in the soil, including the plant. There are a lot of interactions taking place between the microorganisms and the plant, and between all the living organisms, the plant, and their soil environment. So now let's describe soil health. What is soil health? It's the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. How can we achieve this? By following the basic soil principles, knowing your context, keeping the soil covered, keep living roots in the soil, minimizing soil disturbance, planting diversity to encourage soil biodiversity, and integrating animals. To me personally, this doesn't feel complete because our soils right now are bacterial dominated. I feel like the one more very important principle is restoring and sustaining a thriving soil food web. So restore meaning we need to rebuild that population, which can then help repair the structure that was lost. Sustain, maintain the population and the habitat. So let's take one of the soil health principles from the previous slide, plant diversity to encourage soil biodiversity. Is it enough? Will diverse covers alone restore the soil's community in this type of soil? They can help, but usually not enough, especially when dealing with bacterial dominated, oftentimes structureless, dead soil. Cover crops will definitely provide food and build habitat for soil biology via their root systems. But what if the key communities in the soil are missing and your plants end up mostly feeding bacteria and you're not rebuilding the full community? So managing with biology accelerates restoration and increases farm productivity. So you want to pair the covers, obviously with reduced disturbance, diverse carbon inputs, so carbon from different root systems, carbon also coming from the decomposition of organic matter by microorganisms, and in this case, also targeted inoculation to kickstart the community, rebuild the fungal biomass and the missing guilds faster. So why should we care? Why is it important to restore and sustain a thriving soil food web? The soil food web, when functioning optimally, supports the existence of all higher trophic life forms by providing these ecosystem services. So retaining and cycling nutrients to support plant growth, water regulation, storage, and purification, disease and pest management, toxin decomposition. Disease and pest management is a really interesting one. Which I also go over a specific case study in the course with a flower farmer, and we were able to deal with and manage powdery mildew on her plants, supporting the production of food, feed, fiber, and fuel, and provision of health. So soil is a massive medicine cabinet. There are lots of different types of compounds that are produced in soil by microorganisms, ranging from antibacterials, antifungals, anti-cancer, anti-helminths. So these are all the reasons why it's important for us to care, why we need to restore and sustain a thriving soil food web so that the plants that we eat and the plants that the animals eat are healthy. And so that then ripples down the cycle of life. So now you probably already know that it's crucial or critical for us to consider the microbiome that covers the entire plant body. Whatever you're growing from root to shoot is covered in microorganisms. We have the rhizosphere, or the root region that is directly influenced by plants, where dynamic interactions are taking place between the microorganisms and the plants and the predators that want to eat the microbes. And then we have the phyllosphere, the total above ground surfaces of the plant. And since the 50s, there's actually been a growing interest in understanding the complex microbial habitats found on the entire body of that plant. And every part of that plant harbors a diverse array of microorganisms, and those organisms interact with the plant, affecting its health and functions. One of the pioneers of organic food and farming, Lady Eve Balfour, once said, "The health of soil, plant, animal, and human is one indivisible whole." So science around the microbiome has revealed that we have never been individuals, each and every single one of us, whether you're a plant, an animal, a mycorrhizal fungi, a fish, a bird, an insect, we all have a microbiome. If you have worms and you're doing vermicasting, the gut or the alimentary canal of that worm contains all sorts of bacteria that are beneficial for your plants. So we are actually shaped and influenced by the microorganisms on and in our bodies. And the term for this is called holobiont. It's defined as an assemblage of hosts and the many other species living in or around it, which together form a discrete ecological unit. So as I like to always say, you're an ecology, I'm an ecology, your cat, your chickens, your dog, they're all distinct ecological units. So how do you restore microbial life in the soil if the soil looks like this to begin with? Do you start with cover crop seeds and hope they germinate? How do you get these organisms into the soil? So one of the best tools that we used is a high quality biodiverse compost. So compost is a huge, huge subject that we talked about as part of the course, how you can basically create or produce your own high quality inoculants so that you could take that inoculant and treat your farm soil or your garden soil with it and watch your plants grow healthily and vigorously. So compost is a result of an aerobic decomposition process exhibiting amending, fertilizing character, and contains diverse soil organisms. So amending means high quality compost, it should contain all these different compounds that actually improve the structure of your soil. It improves the water holding capacity of your soil as well as its ability to retain nutrients. And it provides habitat for different types of microbes. Fertilizing character is another characteristic that high quality compost should have. It supplies your plants with available nutrients and it creates those surfaces that hold nutrients for roots and microorganisms. And it should also contain diverse soil organisms. So if you have your own compost right now, and if you don't have a microscope, look at all the different bugs that are present in your compost pile. Are you seeing different types of arthropods? Are you seeing worms? Because if you have higher trophic level predators in your soil, then you're actually moving in the right direction. Sorry, higher trophic predators in your compost itself, then you're moving in the right direction. And then you can take that material and turn it into a liquid inoculant. So again, high quality compost is not just about returning organic matter to the soil, but it reintroduces a wide range of beneficial organisms to rebuild the soil food web. So think of compost as a pre and probiotic supplement for your plants and soil. You're essentially replenishing the microbiome of your land. Successful composting systems depend on creating conditions that are favorable to the growth and activity of diverse microbial communities. So just like soil, when you're building your compost piles, you need oxygen, you need moisture. Well, your microorganisms will need both. And obviously diverse diet, diverse ingredients to create your inoculant. So this little video here is actually a microscopic image of an inoculant that I would produce for a client. And I like to just check it out under the scope to see how what it looks like. What are these diverse structures, whether or not it contains diverse organisms, and that's exactly what I'm looking for. So here's a sample compost recipe. This is a typical recipe that I use in late fall. It changed recently. I always play around with recipes, and so can you. You can play around with your different recipes, kind of like making your own delicious soup, right? You understand the recipe in the very beginning, you look it up online, you cook your soup, and you get it right the first time, first 2 to 3 times, and then you can start changing things around, taking some stuff out, taking some ingredients out, and then adding different ingredients to make it taste a little bit differently. Um, so the recipe also changes depending on the season. The hay here is gonna be replaced with, say, 10 different ingredients of weeds in the summertime. So if I were to go through each category, I have the high nitrogen, I have the green, I have the woody or brown. So the high nitrogen category, this is the protein source for microbes. This is easy to metabolize bacterial food. This is what will give the compost pile the initial kick due to their intense microbial growth. And millions of microbes are basically respiring at once, which fuels that initial thermophilic stage. And the reason why I would want that thermal temperature in my compost pile is so that I can deal with weed seeds and potentially pathogenic organisms that are present in the organic matter, especially if I'm using manure. Greens, 30 to 35%. This is what's going to maintain that thermophilic process. So intermediate organic matter, which is going to feed both your fungi and your bacterial communities. And then finally, you have the woody or brown, roughly 50 to 65%. This is your fungal food source. This is the recalcitrant organic matter, so it's harder to decompose. And this category is what's mainly going to feed your fungi. And one thing I also want to point out, when we're looking at this recipe here, you notice how I'm not just using one ingredient per category. So I'm not just using horse manure for my high nitrogen. I'm not just using hay for my green. I'm not just using straw for my woody. I'm using at least three different ingredients per category. And the reason for that is because I really want to diversify my microbial community as well as the predators that want to eat the microbes. So diversify the ingredients as best as you can in your compost piles, whether you're making a thermophilic compost or a vermicompost or static compost. At the same time, you want to diversify the organic matter that you're using when you're managing your soil. Okay, so it's pointless to produce high quality compost if you're not managing your soil in a way that would be conducive to microbial growth or sustaining the soil food web population. So high quality compost heals soils that lack a thriving microbiota that support plant growth. Let's move on to liquid bioblends, compost extracts, and teas. What is the difference between an extract and a tea? Well, an extract is basically just the process of extracting organisms, soluble nutrients, and whatever other compounds that are in your compost into the water, and that's it. All you're doing is you're agitating that compost material. You probably have a brew bag that you're using to put your compost in, and then you're just extracting their population and extracting all the foods that basically the products that they produce from decomposition into the water. Compost tea, on the other hand, this is the process of brewing an extract. So you're doing that first step. You're making an extract, but you're also adding what I call microbial supplements. They're foods for your microbes. And you're brewing it for an extended period of time to encourage the growth of beneficial organisms. So the growth would be, depending on the quality of your compost, bacteria growth, fungal growth, and protozoa. Nematodes will not grow in a tea because they have longer reproductive cycles. So a quick disclaimer, the quality of your liquid bioblends, your extracts and teas, is determined by the quality of their base ingredient, which is your compost. So this is what I mean when I say quality. Hopefully these videos are gonna play here. Let me just change my mouse. There we go. So basically I looked at two different types of compost under the microscope just to show as a demonstration. You have the municipality compost on the left-hand side, and then you have this high quality compost on the right-hand side. Okay, so it's basically the one on the left is really dry. It lacks microbial life. It lacks the predators even. So that's another thing that I would highly encourage everyone. Why it's important to use different types of ingredients in your compost piles is so that you can attract different organisms that want to eat the bacteria and fungi. On the other hand, you have this compost or compost extract. This came from high quality compost, and that compost was managed in a way where the microorganisms were actually provided with sufficient moisture. They have diverse diet, which then promoted soil life. So this little strand you're seeing here, that's a fungal hyphae. So I guess which compost would I use to make my extracts and teas with? Obviously, I would want to use the compost on the right-hand side because it has more life. It has more aggregates. It has more structure. It has more food compared to this municipality compost that looks pretty bare and pretty dry when I actually received it. So let's compare the differences between the two liquid bioblends. You have the tea, which is a foliar application, versus an extract, which is a soil application. And I go over the details of this as well in the course. Add foods at the start of the brew to grow beneficial organisms for your compost tea. So you really want to multiply their population. And through their multiplication in a tea, the microbes, when they're activated and they're reproducing, they're growing, they're producing glues, and it would help them stick to above ground surfaces of the plant. Versus a compost extract, no foods are added at the start. You're not brewing it for an extended period of time. You get what you get from your compost, but you can add foods at the very end. After you've done your extraction, you can add your microbial foods and then you apply it around the root system. So with the tea, it's generally used to prevent disease-causing organisms or pests on the above ground parts of the plant. So we're talking about the phyllosphere. Versus an extract, this is an effective means to get beneficial organisms into the rhizosphere around the root system of that plant. With the tea, you can use it in soil with low organic matter levels. So this is something that you would have to send to a lab to analyze the organic matter percentage in your soil. Versus an extract, you want to make sure you have sufficient organic matter. You want to make sure you have a plant in place before you apply the extract. So liquid application can be advantageous because you get that immediate nutrient availability. The soluble nutrients in your liquid bioblends can be easily accessible by the plant roots or the organisms in the soil. There's also flexibility in application. So liquid applications can be delivered through irrigation systems. You can use pivot irrigation, drip irrigation, any equipment tailored to your context. So instead of, for instance, just using water to irrigate your plants with, you can use an extract. It's cost effective, so transporting and spreading large volumes of compost can be logistically and economically challenging. In contrast, if you have a small volume of high quality compost, you can turn it into a liquid form and you can spread that product to your soil. And you can customize your recipe. Recipes can be tailored from the actual production of your compost itself. So you saw earlier the recipe that I used for my compost pile. And then later on, you can actually tailor it even more depending on the growth stage of your plant. So you can customize it however way you want. It's very, very flexible that way. Okay, so now off to the case study at Little Dog Farm. This is Kathy and Ian Finley. These are my farmer collaborators. We're still trying to figure out how we can basically have an in-person workshop on their farm. 3-day course at their farm where we can demonstrate everything that we've done so far, build thermophilic compost, and look at their entire farm as a whole. They actually started this farm back in 2019, but they were already regenerative farmers before then near me. So they decided to go from a 5-acre plot to a 60-acre plot in Creston. Here's a quick summary of our first conversation. They wanted to do or have a mixed species orchard for cider production. So soil health is an issue. Virtually no life, poor organic matter levels. So this is their baseline numbers. This is 2 different orchards. I believe this is the South Orchard with less organic matter level, and then the North Orchard about 3.8%. Pioneer weed species present. They do want to produce their own inoculants. So this is another thing too that I really encourage farmers, if they have the time, if they have time is really the biggest limiting resource in farming. But if you have the time, if you can somehow fit it into your schedule, producing high quality inoculants for yourself is worth the investment. And typically for Ian, he does this practice around fall. So he would produce enough volume, enough compost to basically allow him to spray the following spring. And then maybe he'll do another one in the summertime if he has time. And we are doing soil testing until the orchards are established and flourishing. So in April 2021, they invited me to their farm to do that initial visit. These were the photos that I took during the time. Soil management historical data didn't exist. So the former farmer that produced on this farm, he didn't really keep track of or didn't have good records on how he managed this farm, but essentially it was intensively managed for hay, heavily tilled for a significant number of years, and the land was left bare, like this when Kathy and Ian took ownership of the property. Here's a different section of the farm. So on the left side photo, that's the second orchard, the south orchard, which is the first site that we started experimenting this type of management, biological management against. You can see how compacted the soil is. This is a different section of the farm where they tried to grow vegetables, and you see here how the carrots that were planted from the year before, they didn't decompose. So I came in April. These carrots were planted around September, May, fall of last year or the year prior, and they showed no signs of decomposition, and that is indicative of the absence of biological activity. So that year, we started with restorative disturbance. Because the soil is heavily compacted, we're basically working with concrete, right? So then how are we going to get into the deeper layers of the soil if we're going to be spraying liquid? It's a waste of time because that liquid is just going to run off. So restorative disturbance is what I like to call this practice. Um, but before I got on the project, Ian did seed cover crops, but the germination was sparse. He spent at least $10,000 on 12 different species of cover crop seeds, ranging from legumes to wildflowers to cereals or grasses, forbs, all these different types of plants, and barely anything germinated. So he did do a couple of passes to break up the compaction, and hopefully the surface area can, a little bit of moisture will catch on that surface area, and that's really what we're looking for. And also we needed to get some air into the soil. All right, so in addition to preparing some kind of habitat in the soil, Ian set out to build compost. This was the initial setup. Each of these cylinders can hold about a cubic yard of material. We started with roughly 4 cubic yards for 25 acres, which is not a lot. This is just for the spring and fall treatment. So we're not trying to build uh uh we're not trying to have like a large quantity. We want high quality, small volume. This is what his current setup looks like. So he has upgraded from the flimsy hardware cloth to this heavy metal that works great for him. It actually holds more than a cubic yard of material. So as part of his composting process, he did record the temperature from each of his compost piles, took photos of the compost logs, sent them to me, and I supported him in remotely managing and monitoring his piles. So this data allowed us to identify when is it a good time to turn the piles, or why is this particular pile, even though the same ingredients were used, is not behaving like the others. Out of the 4 piles, we were only able to use 2 piles for the treatments. So we really only had less than 2 cubic yards for 25 acres. So here's the raw data. Let me just get to the next page here. This is what Little Dog Farm had to fix on the left. The compost piles with the strong protozoa and nematode populations both contain bacterial predators, so organisms that feed on bacteria. It's forcing that community to be active. That predation, it drives the bacteria to keep reproducing. And as they reproduce, they basically make sticky biofilms or extracellular glues, sustaining decomposition. And those microbial byproducts It binds particles and organic matter together. It basically restructures the soil. It improves those micro aggregates, rebuilds them essentially. So the predators keep the bacteria working, the bacteria making the glues because the predators are forcing them to be active, and those glues rebuild soil microaggregates. So one thing to also keep in mind, it's critical to combine organic matter building practices such as cover cropping with your liquid bioblends. So I would combine as many principles as you can if you are restoring soil that looks like this. Maybe get some animals in there as well, which Ian had done um, later on as part of his remediation restoration process. So these videos here, our application rates were roughly less than 100 liters per acre. This is a liquid blend, liquid bio blend. You can see how dark that liquid is. Um, I looked at his predators under the microscope. Obviously, there's quality assurance that needs to take place. I was seeing a great population of bacterial feeding nematodes. And here he is on his tractor spraying his liquid bio blends. And so I think, yes, for volume, he was spraying, I think, roughly 98 liters an acre. And he was going pretty fast here. I've had to tell him to slow down because we want to make sure there's good coverage on the entire field. So he was going. I had to tell him to slow down to 3 kilometers an hour. The following year is the photo on the right. So I visited the farm in spring of 2021. The next year, you could see how the cover crops that didn't germinate, they germinated, they woke up. This is the same field later in the year. You can see how much biomass has been created after just 3 treatments. That's it. Basically, Ian just treated the field 3 times. This was our first step in rejuvenating the soil. At this point, it was just allowing the plants to do their thing, allowing them to set seed and reseed for the next season before preparing the field for tree planting. Here's a different section of the farm. This is called the South Orchard. On the left-hand side was what it looked like in the beginning. The fall of the following year, he had these posts in there for his trees. He started to set up the infrastructure for his trees, so disturbance had to happen, unfortunately, but they were seeing that moisture is being held in the soil. A year later, I received these messages from Ian, visible fungal growth above ground in the South Orchard. Puffballs appeared one morning when they decided to do a morning walk in the orchard. And it was this moment, I would say it took me 2 years to realize that we're moving in the right direction. When they saw at least 5 different species of fungi on their field. We don't know where they came from. They may have come from the extracts or the teas, or maybe the spores were already dormant or they were already present in the soil and they woke up when the conditions were right. So a quick recap, life finds a way when we restore the foundation below. In 2021, this was our baseline. We were working with cracked, deserted moonscape with barely any life. By 2022, the dormant seed bank woke up. Decomposition activity was picking up. The exudates were doing their thing from the root system. 2023, increased plant and fungal diversity. So we're seeing the cover crops that they planted, a lot of them were flourishing. In 2024, the salamanders arrived. Spiders appeared for the first time. So the food web complexity just kept building. And then this year, young fruit trees are finally taking off, still not ready for harvest because they are quite young. But we are seeing a lot of keeners in the orchard, such as this tree here. It just wanted to produce fruit. The cover crops continue with their ecological processes of nutrient cycling and decomposition, building soil, creating pore spaces with their root systems. Slugs are now appearing for the first time. So they're now entering the food web. Ian was really excited. Slugs are something that a lot of producers would not be excited about. But given his mindset in general, Ian just says, "Oh, great, slugs! Now I can get ducks." Right? So he has that mindset already. So seeing all these changes above ground, it's affirming to him. He's now understanding that, okay, we can actually make this work. And finally, a new crop of puffballs appeared. So we didn't see any in 2024, but 2 years later, when they first appeared, um, we are seeing them again. And with that, thank you all for giving me the space and time to talk about soil health. I'm sorry I've had to take a few breaks there, but I'll pass it off to Javin.
Jo, thank you so much for sharing your experience, your wisdom, and Little Dog just continues on. That's the best thing about clients and ecologies that are keen. Ecology is always keen. It's always the client conversation. But to see the changes every year and just to see that complexity, it's almost like a bingo card. We know all the requirements and we're just slowly seeing them as they go throughout. So, thank you so much. Obviously, people are pretty thrilled. We're seeing it in the chat with your presentation and just your incredible wealth of knowledge. So thank you. We've got a couple of excellent questions in the Q&A. If everybody wants to pop over there and upvote the ones they want answered first, I'm sure we'll get to them all, but it'd be good to high grade them. I'm going to give everybody a quick tour of what the course looks like so folks can get a better sense of what the course is and how it works. I'll tell you a little bit about the improvements and the aspects of it. And for those that are keen, it might be the right time to jump into it. Winter is a wonderful time to go into these types of courses and to work through, especially if you've got friends that you're like, hey, let's take this course together and go through it. We find that people that get a small group, small cohort to go through the group really get a lot out of it. So I'm excited to share that all with you today. So jumping back in, you can see why a course like this has so much value because we have to understand the complexity of what we're doing so that way we can apply it diligently and intelligently to the site. And like Jim said, in 68 years of learning about soil, farming for close to 70, this was the greatest learning experience he's ever had. And people struggle with soil because they're working on symptoms, not systems. And that's what Jo was showing with Little Dog is that it's a system of approach. And when you work through that system of approach and you cover the core biology and as well as the non-living systems and the interaction between them, you get to a place where you can really understand how plant performance is a product of good soil structure. So in this course, you learn biology, structure, the soil food web, aggregation, decomposition, the rhizosphere compost, teas and extracts, disease, and ecosystem level thinking. Nothing is missed. And that's what I love about Jo's approach. She's very, very thorough. And when she teaches this course, the difference here is that students continually say from the end of it is that it's so well organized. It's one of the most comprehensive courses they've ever taken. And that's that blend of Jo's rigorous science with warmth and approachability. And you never get lost in jargon. So if anybody has any trauma from high school or university science, this course isn't that. This is very much being helped along to understand what's going on. The source gives the most soil courses that give you information, but what Jo has put together is really a course that gives you understanding. So included in the course, we have 10 modules. In each, we have an hour or an hour and a half sometimes of lesson and up to an hour of Q&A, which is incredible because most of the questions you can think of have already been asked, so you have access to that. We also have tools and resources to turn the learning into real results. Jo has provided soil diagnostics, compost templates and logs, a compost manual, and a course glossary. So for those of you that are brand new, you can always come back to this. We also have a curated video library. So it's one thing to poke around on YouTube and kind of shoot in the dark, but to have somebody who does this work all the time, really curate and even create a lot of these videos, you have an ability to rest easy that you know that this is the most professional level videos to look at and to interact with that include microscopy, compost cycles, cover crops, microbe behavior, brewing guides. There's just so much value here because it's already been high graded for you. And you also get over 60 pieces of curated knowledge. So there are, I don't even want to guess, but I'm sure we're in the millions of scientific papers. How do you tell which is which, especially if you come at it from a lay environment? So somebody like Joe has been able to go through the scientific papers, the field articles, the indigenous teachings, water cycle science, and climate framework to really drill down to the absolute best. So the total value of this is over $1,800. We have 698 in the training, 376 for tools and resources, 504 for the libraries, over 240 for the research and deep knowledge. And what happens here is you get instruction and the answers to know, you get the tools to act, you get the videos to see, and then you get the research to deepen everything. And that's the great thing about the course is that it comes at you from so many levels and areas that you have a deep understanding of this material by the end of it. So the total value is over 1,800. The regular price for this course is $299. Today until Sunday, it's $249. But for 15 people who are super keen on this, they know it's right for them, they want to spend the winter working on this, we have 15 spots at just $199 if you use the code SOIL15. Just imagine this. Instead of guessing about biological needs for your soil, you actually understand the living soil system. Your plants respond faster, problems show up less often, like we see with Little Dog, and you know it's because the biology, the structure, and the system underneath your feet are finally working together with you, the producer or the implementer who actually has an understanding of these systems. If that's what you want and you want it quickly, you don't want to waste time or your money or another season, this is the course on where to start. And you're in good company. The students who came into this course loved it. They loved the conversations. They loved being able to know what they were interested in and what Joe was able to pass on. It was an incredible experience now twice that just consistently gets refined. But we know that working with Living Soil can be intimidating. We stand behind this course completely. So here's the grow to no guarantee. Complete the course, apply what you learn, and if your soil doesn't clearly show improvement, better structure, more moisture, visible life after a full year, we'll refund you in full and I'll send you $100 out of my pocket. That's how confident I am in what Jo can do because Jo understands this work. She does it every day. It's based upon her work with clients. We know it works. So if you want to understand this work, if you don't want to be worried that there's a problem, I will pay for your course. I will refund it $100. If you go through the course, apply everything, and there's zero change. That's how confident we are in this process. So for 15 folks that are super keen, $199 using Soil 15, you can use the link and I'll put it into the chat. If you don't get to the 15, but you're very keen on this course, it's $249 until Sunday. And then after Sunday, it goes back to that $299. So I'll put the link into the chat there for anybody who's keen, and then we'll jump back to the questions. Right, it is in USD. Great question. Okay, so let's take a look at our questions and what's been upgraded or highlighted. Okay, so we only have one question that's been upvoted. So Joe, I'll read these out if you want to share. From Nicholas, if you're pushing, I'm guessing compost liquid bioamendments through irrigation, what method do you use to attach to the irrigation itself?
What method? Nicholas, are you asking pump? And this, if you're asking pump, I'm assuming equipment. Um, okay, yes. So Nicholas says yes. I would opt for either a diaphragm pump or some type of venturi pump, not a centrifugal pump. You want to make sure that the mechanics inside the pump is not going to be crushing or destroying the larger organisms in your liquid. So a diaphragm or a venturi. A lot of times a diaphragm is sufficient.
Awesome. Thanks, Joe. And I'm going
Hmm.
to check again. Okay, so all the questions are equal. So I'll just start from the top and move down. Daniela, I have a very special case. I work on projects in West Africa, Guyana. In huge areas of the country, soil and water is contaminated with mercury due to gold mining. How can mercury affect the soil and what ways can it be removed?
Ooh, I'm not familiar with this type of remediation, Daniela, I'm sorry, but I would look into how would I approach this subject? I would even look into Google and looking at mine remediation using biological management practices. I know that fungi has the ability to hold on to mercury. I think mercury is a bit tricky. Um, they I don't know if organisms actually eat the mercury, but they can immobilize it. Fungi in particular can immobilize the mercury. If you can build structure or strong aggregation in your soil with the microbes, then I would assume the mercury would be immobilized because they'll attach to the surface of to the surface of the aggregates, surface of the organic matter, which can reduce leaching potentially and contamination, water contamination. Javin, do you have anything to add to this?
Yeah, so I did a little bit of work with this, and then also Lila Darwish is a friend and colleague, as
Oh,
well as
yes.
Kelpie Wilson, who works with biochar. So one of the issues with mercury is that it could be metallic mercury or mercury salts, and they can lock into clay particles and organic carbon, which can keep it from leaching, which means it can
Mhm.
persist for quite a long time, decades sometimes. Also, under anaerobic conditions, it can become compacted like waterlogged mining soils and whatnot, and it can convert the inorganic mercury to methyl mercury, which is far more toxic and can bioaccumulate in crops, worms, fish, livestock. And in terms of what it does in the soil, is that even in low parts, it can suppress microbial respiration. So if you're familiar with the Solvita soil respiration test, which is a great way of understanding how much microbial activity is happening in your soil, if you don't learn or work with microscopy, you'll see a drop in that, which takes quite a bit. Also, mercury can reduce nutrient intake. There's a greater susceptibility to drought because it reduces the ability for moisture uptake for most plants. And that's why like mining tailing areas can remain barren for years. There's no one simple way in terms of remediation. Most like conventional remediation is the physical separation of the mercury particles and like doing washing effects basically. And that's usually what they do for hotspots, but it's super expensive. Sometimes you can use stabilizers and binders. So like sulfur, iron sulfide, can create insoluble mercury sulfides, which doesn't remove it, but it locks it chemically. So there's a way to actually bind it so that way it's not available. Biochar has been shown to absorb inorganic mercury and reduces its bioavailability. And that still has the application or the issue of having to apply it. So you have to like get the get the biochar and actually work it into the soil, depending on what the depths it's at. Hyperaccumulation or hyperaccumulators like Indian mustard, so Brassica juncea, Chinese brake fern, I think is another one, Petrus vittata, and then vetiver. They can take it up, but you still have to remove the plant because it is bioaccumulated now in it. Remediation has also been shown to be quite has a lot of potential with mercury. So that would be the Pleuroides ostrus and Trametes versicolor. Those would be the two that I'd probably work in. A number of tailings ponds, unfortunately, if you're in a dry spot, this doesn't work, but have used wetlands like John Todd's green machines to actually take up the mercury within that wetland system. But there's no one way. There's just a lot of issues with it. So like I'd probably take a look at stabilization only because most of those stabilizers you can find in elemental form and you can apply granular probably during a rain. And then probably do my testing in small areas, then build up a treatment protocol, then expand it with proof. But it's a great question, and I really appreciate it. And I appreciate that you're doing this work. That's terrible. Lila's working in Palestine right now with missile remediation, and I'm sure she would have a lot to say about it. So if you do ever get a chance to reach out to Lila Darwish, I'd highly recommend it. Okay, next question. Okay, we've got some questions that have been upgraded. MJ, can this be applied to remediation restoration of natural landscapes, or is it mostly agricultural focus? If so, is there another course that you provide?
Is this in the chat? Sorry, Javin, or is this in the Q&A? Oh, sorry, what was the question? So I was
Yeah.
in the middle of answering a question.
No worries, no worries, no worries. Let me grab it again. Where's MJ there? Maybe at the bottom. Can this be applied to remediation, restoration
Oh,
of natural
yeah.
landscapes, or is it more agricultural focus? If so, is there another course that you provide? Maybe you could talk about your presentation at the mining conference recently.
Yeah, I mean the mining industry, I would say that's a very new venture for me. I cannot say at the moment that I am actively working on any projects in mine reclamation. However, the principles, the methods are applicable in all landscapes. As long as you're working with plants and soil, the principles stay the same. Which is for me personally, it's you're hiring your microbial workforce. So that's what's going to help you build your soil. So you want to create a habitat, you want to create an inoculant that will keep them happy, and you want to deploy them at the right time. And so the idea is to really get your communities growing, get them to multiply. And because they are much better at growing plants than we can, we then we then apply them into the soil and they can do whatever they do best. So it's applicable in all contexts, as long as you're working with soil.
Awesome. Thanks, Joe. Really appreciate it. And thanks so much, Angeli, Katrina, and Rawls for jumping into the course. Pleasure to have you in it. I'm glad to see your enthusiasm. Okay, our final four questions here. So, next question, Joe, from Claudia. A friend brought soil for a new bed and had a lot of trouble growing veggies in that bed as compared to older beds. Is there a suspicion of some chemical contamination? Do you have any other suggestions that would help to remediate the soil?
Bought soil for a new bed. It may be chemical contamination, but it also could be if that soil has compost in it, that compost may have not matured properly. So immature piles also tend to be harmful. They can actually inhibit seed germination as well, and they can cause problems to your plants. So it can be either just that the producer didn't let it mature long enough. Um, and so to remediate this type of situation, I would I would even see if you can find a different source of material that you know produces high quality products. Um, yeah, that's what I would suggest. What are your thoughts, Javin?
Yeah, so I think, Claudia, when we're taking a look at issues with soil, John Beebe's framework, the AWOM framework, is great to take a look at. So, soil is a womb: air, water, organic matter, minerals, and biology. And what I like about John's approach is that for so long, soil science was fully, well, when it started, when we go all the way back to like 1804 or 1806, the Russian ecologists talked about soil being a system. And then come about the turn of the century, the 1900s, and then into World War II, we go from there all the way over to soil as a medium through chemical addition to produce plants. So we forget biology completely. And what's interesting is that John's approach and Joe and Dr. Elaine Ingham kind of brought it back over kind of farther to the biology, and we need to find the center a little bit. So John's approach, pardon me, of a womb, I think is a really intelligent way of taking a look at it. And so I would walk through the womb framework and go, what are we looking at for air? So what's bulk density looking like? What's infiltration like? Do we have good infiltration? What's organic matter in terms of material? And can we estimate that organic matter or can we get tests on it? Mineralization. John has a great book called Test Your Soil with Plants. In it, he takes a look at all the common plants because we have such great data and photos on deficiencies of those elements. So you can actually take a look just by judging what the plants are being grown. And sometimes you have to grow common plants. You have to grow soy, potatoes, um, corn, or there's a fourth I'm missing here, and take a look at the photos of the plants themselves to go, right, that's nitrogen deficiency. Absolutely. Or, yeah, that's iron. And I think that would be super useful to understand what might be happening there. And then there's the biology piece as well. So to understand what might be missing. So I think if you can go through that and walk through that as a process, that for me is kind of my go-to now, working with soil now for 16 years, is to take that a womb framework and then slot the different education I have in each one of the acronym titles and understand it from a deeper level. So I would do a little bit more investigation to understand and see if any of those make sense. Um, the Becoming a Soil Detective, a womb course with John just finished last week. And so probably, I don't know, in a month or so, we'll have it available as a self-paced course if you're interested. Okay, Joe, next question from Nicholas. Wonder if you have a common grass cover on land. Do you have to pull up all the grass, then add compost, then seed? In the Little Dog case study, they seeded first and sprayed. Is that on purpose?
Um, Common grass cover on land. Do you have to pull up? No, we didn't have to pull up the grass. Then add compost. So with the Little Dog Farm, we really allowed whoever wants to be there to be there. Because our goal is to increase organic matter. The organic matter levels in that soil was so poor that we just let whatever you want to live there, you're a weed, that's fine. Just grow. Um, and we needed to allow those different plant communities. And what we also did was at some point when they grew to a certain height, Ian actually sprayed a treatment of tea when they grew a certain height, and then he mowed it down. And then he just kept mowing it down and allowed the biomass to accumulate on the surface and basically allowed the microorganisms to pull them down, or earthworms, whatever was there. They actually started arriving as well on site, allow those organisms to pull the organic matter into the deeper layers of the soil. We didn't add compost because it is a large scale. I mean, it's a small scale, but we didn't add compost. Compost would have been so expensive at that point. We just built compost and then turned that compost into a liquid formula, into a liquid inoculant. In the Little Dog case study, they seeded first. So that was the idea behind remediation for Ian. Was he knew that he needed to increase organic matter. And so that's why he seeded first. And then when he was waiting for his seeds to germinate, none of them germinated because the soil just wasn't holding enough moisture, and it's compacted. So it wasn't really, it was just sort of intuitive on his part. And then that's when he got me on board and he said, we're having issues. Can you help us out? And then we just sort of went with the liquid bioblends after that. Um, I hope that answered your question.
Thanks so much, Joe. Appreciate it. From Chains, we are currently experiencing challenges with diseases in our greenhouse specific to Solanaceae tomatoes that are growing in containers. Is there anything in particular we could help to apply to prevent disease prevention?
Ooh, this is a big topic. Disease suppressive soil is something that we also cover in the course. Um, I would even go back and understand what type of inputs are you using. If the inputs you're using are more leaning more towards the bacterial community, so the easily digestible inputs. So what comes to mind for me are maybe composted manure, maybe feather meal, maybe some blood meal, all these types of meals that you're using to uh, to help your tomatoes. They're actually inhibiting your fungal communities to grow. Um, and when you're inhibiting that fungal community, the tomatoes themselves, the plants, they can't grow those tough structures, cellular structures, to make them less susceptible to disease. So I would look at that first, understand what your inputs are, understand when do you apply those inputs, at what point in the growth stage of your tomato are you applying those inputs? Are you applying them after they've produced their first set of true leaves? Right when at the vegetative stage, when does the disease appear? Is it appearing at a certain time at a certain stage of that tomato? And also, are you seeing it in other plants as well? How are you irrigating that greenhouse? So there are all these, it's almost like you have to really step back and analyze the context that you're working in to understand why the disease is there in the first place. Personally, I think disease is present because there is an imbalance in the system. You don't have the other biological communities that can help suppress or inhibit that disease. But really, at the end of the day, what you want to do is make sure you support that plant. You want to give it the right type of foods, the right type of diet, whether that's through compost extracts, and whatever it is that you're adding to actually build that tough structure so that they can withstand the disease themselves. Because plants have the ability to also deal with, they have immune systems, and then they can actually fight off these types of diseases. Javin, is there anything you want to add?
Yeah, I think tomatoes again are one of those amazingly researched crops, and it's quite easy to identify those types of issues with those types of crops. The other thing I'd be very curious about is if it's on every single plant or if there are a few that are making it through. If so, I would 100% focus on those plants to save seed. The main thing we're finding more and more in terms of plant breeding, including dryland farming, is that without actively saving the seed from all of our many mini experiments, our yearly growing programs, we don't have that genetic resiliency that's coming through the plant work of interacting with its environment. So I'd be conscious about that. And then again, it comes back to a womb for me is really understanding the different elements of a womb and being conscientious about them. So, yeah, I would be very curious to see photos. Okay, Joe, why don't we answer the chains question there live? Because I think you're answering a question, but that was the last one. Are there any ways that you would adjust compost production application when growing crops in containers versus growing in the ground?
I would use less in the container. So you can use the same recipe. You could use, whether you're using a vermicompost, a static compost, it doesn't matter, but just use a little less in a container situation and watch your plants grow, how they adjust themselves or acclimatize to that input. Um, you could even, in containers, you could even take some of that material and extract it in a liquid solution or in water, and then just water it in around the root system of your plants in the containers. In the ground, it's better to grow in the ground because you have all of these different components that are present naturally, like as Javin mentioned, a womb. So you have the minerals in the ground as well. And this is in the containers, you may have to use different types of minerals. Some folks use rock dust to provide the minerals. Maybe you can use incorporate a little bit of clay in there if you could. So providing that solid constituent in not just organic matter in the containers, but also the mineral matter in the containers. That's what I would do. Just use less in containers and then just monitor your plants.
Thanks,
Javin,
Joe.
is there anything? Yeah.
No, I think that was perfect. Nothing else. Okay, our last question from Jessica. And thanks so much, Jessica and Missy, for jumping into the course. That means there's 10 spots left for anybody else that's keen to pick up those first, 15, now 10 spots. So if you are keen, again, soil 15, and you can get the course for 199. From Jessica, is composted cow and sheep manure that have both straw and sawdust in them high in bacterial, or could it promote fungal favorable environments? I have a couple areas that have been grazing our sheep and found a few species of fungi.
Um, it depends on how that material was managed. I would say would have some fungi in them for sure because of the straw and the sawdust. Um, but I would also look at the ratios of the manure versus the straw or sawdust, right? So if you're dealing with, say, 65% more manure and you get a little less saw or sawdust in there, then you are leaning more towards the bacterial dominated in material. But if you have a 50-50, maybe there's a balance of both. But if you have more straw and sawdust, then obviously you're leaning more towards the fungal community and making sure you're also incorporating air into that material to allow those fungal organisms to thrive. Um, So I'm pretty sure you get that concept. So yeah, that's what I would deduce from that.
Great thought. Awesome. And for anybody else who doesn't or we didn't answer live, Joe has answered your questions in the answered section of the Q&A. So for Frank C, for there's two more there. I'm not seeing them. Oh yeah, for Frank C, for Mildred, for Chains, and for Susan, as well as Jessica. Joe has answered your questions in writing in the answered section because she's sick, but she's still that good. So great. So folks, such a pleasure to have you all here today. Thank you so much for being interested in this work. It's just so incredible to have so many people who are keen on this type of work. And again, if you're one of those individuals that wants healthier plants, stronger soil, fewer problems, more resiliency, if you want to be in a state as all of these other students have, being very happy with the choice they made to learn this work from Joe. If you want to know that from the grow to learn, grow to know guarantee that you will absolutely benefit from this, then again, we have looks like 10, no, pardon me, 9 more spots for folks that would like to take advantage of that 199 price. And if you don't get in for that, the course is 249 until Sunday, and after Sunday goes back to 299. So thank you so much for being here. I think folks are starting to chime in a little bit about you, Joe, which of course is the case. Thank you. Very helpful. Thank you. Excellent. Thank you. Yeah, lots of folks who are so excited to have participated. And as I am, I've been working in regenerative land design now for close to 16 years. And there is a definitive mark pre-Joe and post-Joe about what I know with soil, how I approach soil and what I do with it. Joe was a student of Dr. Elaine Ingham. And as I learned after taking some courses myself with Dr. Elaine Ingham, Joe went much further. Joe has done an incredible amount of work to grow her knowledge because she focuses on soil itself and she focuses on the production of it. She's very much focused on what we can see changed. So thank you so much, everyone, for joining us. Hopefully we'll see you in another webinar or course. It's a great pleasure to have you here. Joe, what do you want to leave people with? What's the bumper sticker? What's the motto? What's the soil song you want to sing? Give it to us.
Oh, I don't know if you want me to sing right now. I just want to thank everyone for being here today. I know this is, we've taken up a lot of, well, we've taken up a significant amount of your time this morning, and I truly appreciate you being here, and I feel honored to be a part of your day. And thank you, Javin, for hosting.
Oh, such a pleasure. Yes, coming together in the Church of Soil Geekery is one of my favorite things. And I so appreciate you, if not a high priestess, definitely a part of the organization. Um, Joe and I have been working together for a long time and we make each other laugh quite a bit. So thank you, everybody. It was such a pleasure to have you here. Replay will go up in a couple of days. So just know that that's coming. And such a pleasure to have you. And Gabriel, thank you for tuning in from Vietnam on your vacation. You get front seat in the Church of Soil Sciencery and Geekery. You are right up front. All right, everybody, such a pleasure. Take care, and we'll see you in the next one. Bye now.